Looking at the next example, they've moved the blank. So that's why I've been working through the reasoning and the logic for the whole thing instead of just focusing on the end, because they are going to start mixing up where the drop down box is going to be and how many drop down boxes you have altogether. So we got to make sure you think and work through the whole thing. So looking at this one, they tell us that SUT and angle WXZ are supplementary. They want us to complete the proof to show that TV is parallel to WY. So this is our given or our start. This is our proof or where we want to end. So just to double check, given, and our proof's there. And I notice that we're proving something is parallel, so I automatically know that in the reason for this one, it's going to be the converse. And yep, they put the converse in there. So, but I need that blank right there, so let's work through there. So they do SUT and WXZ. So SUT and WXZ. They tell us that those are supplementary. And in the next step, they take SUT and then WXZ and add them together and set them equal to 180 degrees. Well, how did they know? So if you look, the thing that changed is they're adding, and then you have 180. And if you remember our definition of supplementary, supplementary means two angles that add up to be 180 degrees, and that's exactly what we have happening. There's one angle, there's another angle, same ones as above, that add up to be 180 degrees. That's what it means. That's what supplementary means. That's the definition of supplementary angles. All right, for the next step, they've got SUT. So I'm going to go over here and find SUT and TUX. And it says those two add up to be 180 degrees. Well, if I look at those two, they make a line. I think that's if we look back and we checked our list, that's that one right there. Definition of a linear pair, or angles forming a linear pair summed to be 180 degrees. That's what you're going to see in the drop down box. So that's exactly what it is. Angles forming a linear pair summed to 180 degrees. All right, so I'm going to talk through the rest of it just in case you have something that looks like any of these and your drop down boxes here. So next we go SUT plus WXZ is equal to SUT plus TUX. So I'm going to go find these in the proof above and see if they're up there, because I didn't give you any theorems or postulates or definitions that do anything like that. So I'm going to find SUT and WXZ. Well, if we go up here, there's SUT plus WXZ, and we know that's equal to 180 degrees. And if we look right here, there's our measure of angle SUT plus the measure of angle TUX. There's those right there, and that's also equal to 180 degrees. So you could say instead of 180, they wrote measure of angle SUT plus the measure of angle WXZ. So instead of this, they wrote that. So for this one, you could do the transitive property. It will also take the substitution. So looking at this one, instead of the 180 degrees, they wrote the measure of angle SUT plus the measure of angle WXC. Okay, well that kind of gets us where we want to go, except we want to show that things are parallel. And if we're going to want to show that things are parallel, we have to show that the corresponding angles are congruent. So if we're looking at it for our corresponding angles, there's our corresponding angle. So ZXW or WXZ. So I want to keep that one. And then angle TUX, there's our other corresponding angle, so I want to keep that one. So that means I want to take these two others away. And if we look, they're the exact same. So we can do SUT minus from this side and it minus SUT from that side, and that'll leave us with angle WXZ is equal to TUX, which is what we were looking for, and that's done by algebra or the subtraction property of equality. And now that we know those two corresponding angles are equal, we can use our converse of corresponding angles postulate to say that the two lines are parallel. So basically, if you have corresponding angles equal to each other and the very next line is parallel, that's going to be the converse of the corresponding angle postulate. So looking at the next one, it says complete the proof that the measure of angle SVW, so we want to show that that one plus TSV, so that one is equal to 180 degrees. And again, we have to show that based on the math that we see here. And if you click on this drop down box, it will show you that these are consecutive interior angles. But that's not what this math does, so we can't use that one. So if we use our given, it tells us that UW is parallel to RT. And they want us to prove that those two add up to be 180 degrees. So the way you start these, they start with angle SVW. So this angle right there is congruent to QST. So with these, you're always going to start with, whenever you're given parallel and you're trying to prove things, you're almost always going to use corresponding angles. And that's what those two are. So if we're trying to show that this one is equal, or sorry, this one is supplementary with this one, we need to get this next one. We need to get that one introduced to our proof, because right now we have the two pink ones, and we need to get this orange one in there. So this orange one is related to angle TSQ, or QST. If you look at those two make a linear pair. And we know with a linear pair that QST plus TSV is going to be equal to 180 degrees. And that one's going to be our angles forming a linear pair. Summed to be 180 degrees. All right, so if we look at this step, we've got the QST plus the measure of TSV is equal to 180. So at this point, I would look back to where they want us to go. They want us to get to that SVW plus TSV is equal to 180 degrees. So I look at what I do have. Well, I've got plus TSV is equal to 180 degrees. The thing that I want to replace that guy. I don't want the QST. That's not what's there for where we need to go. So I look up in my proof up here. is there a place where I say that we say that QST is equal or congruent to another value? Sure is, right there. QST is equal and congruent to SVW. So instead of QST, we can write SVW. So instead of this, we wrote that, and the rest of it stayed the same. That's substitution. Looking at the next one. They want us to complete the proof that RT is parallel to UW. And they want us to show this, so this is our proof. And then here's where they gave us our given. So if I'm looking at proving RT is parallel to UW, I know automatically whatever this is going to be converse. Because in order to show that things are parallel, it's got to be converse something. So if I look at what they give us to start with, the first step is angle QST. So QST, they tell us that it's congruent, and they already showed us in the picture, but I'm going to mark it because I'm already looking, is congruent to UVX. It's going to be that one right there. Okay, and we want to show those two lines are parallel. All right, usually when we show lines are parallel, we're going to try and use, and this is just a general how you usually saw things, you're going to use the converse of the corresponding angles. You're going to try and create corresponding angles with whatever's going on in here. So in order to create corresponding angles, well, we either need to have this angle, RSV, to match up with UVX, or we can have angle WVS to match up with TSQ. So either of those will give us corresponding angles. And in this case, they went with angle QST. So this angle right here. And they tell us that it's congruent to angle RSV. And the way we know that is because they're vertical angles. So now I have this angle in my proof. And I said I wanted corresponding angles. So there's my corresponding angles. So all I need to do is say that this angle is congruent to that angle. But I've got to have a good reason why. So I'm going to want to have RSV is congruent to UVX. So here's my RSV. I kept it and I brought it down. So that means I had to replace the QST with something. Well, here's QST. So instead of QST, we can write UVX. And that's exactly what happened. So instead of QST, we wrote UVX is congruent to angle RSV. So instead of this, we wrote that. And that's our substitution property. And then for the last step, this angle right here corresponds with that angle right there. So it's the converse of the corresponding angle postulate.